I'm breaking down two essentials from the Indian standard is 875 dead loads and imposed loads, and why knowing your unit weights is the backbone of safe, efficient design. Let's start with IS 875 Part 1, Dead Loads. So what are dead loads? They're the permanent, unchanging forces your building carries all its life, the self-weight of beams, slabs, columns, walls, plus non-structural stuff like cladding, partitions, ceilings, and even fixed equipment like water tanks. Now, the magic number for calculating dead load, unit weight, is 875. Part 1 gives you standard values for pretty much every common building material: concrete, steel, timber, bricks, stone, mortar, plaster, tiles, you name it. For example, plain concrete is about 24 kilonewtons per cubic meter. Steel is a whopping 78.5, timber varies from 5 to 10 depending on the species, and bricks fall between 15 and 20. If you're dealing with things like gypsum board, it's usually 7 to 12, and stone can go up to 27. These values are all laid out in handy tables. Table 1 for individual materials. Table 2 for building components like walls and roofs, and Appendix A, which covers all sorts of stored materials. Yup, if you're designing a warehouse or silo, IS 875 has your back with unit weights for grains, chemicals, textiles, and more. Even factors like dry versus wet sand are covered. To calculate dead load, just multiply the volume of your element by its unit weight. Quick example. Say you have a brick wall, 3 meters long, 3.2 meters high, and 0.23 meters thick. That's 2.208 cubic meters. If brickwork is 20 kilonewtons per cubic meter, your dead load is 44.16 kilonewtons. Simple, but so important. Why does all this matter? Accurate dead load estimation is crucial. Get it wrong, and you risk either unsafe structures or wasting material and money on overdesign. Plus, you need to comply with national standards. This is what's tested in exams, and what keeps buildings standing strong. Alright, shifting gears, is 875 Part 2, Imposed Loads, or what most of us call live loads. These are temporary, changeable loads. People, furniture, movable equipment, even temporary partitions. The code sets minimum values by building use. For residential rooms, you're looking at 2 kilonewtons per square meter. For offices, anywhere from 2.5 to 5, and for storage or heavy use, it can shoot past 7.5. Corridors and staircases? Usually 3, but up to 5 if there's a crowd. There's a clever trick in multi-story buildings, is 875, lets you reduce imposed loads on columns and foundations as you go down. The more floors above, the less likely every floor is packed to its max at the same time. For example, if a column supports 4 floors, you can reduce the total imposed load by 30%. But heads up, no reduction if you're dealing with warehouses, garages, or heavy machinery. Special cases? Roofs get their own rules accessible. Roofs are 1.5 kilonewtons per meter squared, maintenance-only roofs, halve that. And always check for impact loads from things like lifts or cranes. In practice, all of this gets entered into design software, like STAD Pro, to make sure every load path is accounted for. So next time you're sizing up a building, remember IS 875's tables and rules aren't just paperwork. They're the blueprint for safety and efficiency in every structure you design. Thanks for watching. Got questions or want more code breakdowns? Hit like, subscribe, and drop your thoughts below.